We are going to determine the domain and range of each of the following functions. The first function we have is a series of 5 discrete points. The way we'll approach this is to treat each point as though it has a horizontal and a vertical component, and in fact it does. This first point has a horizontal component of -5 and a vertical component of +5. The second point has a horizontal component of -3 and a vertical component of +3. This point has a horizontal component of -1 and a vertical component of 4. This point has a horizontal component of 3 and a vertical component of 2. And finally, this point has a horizontal component of 5 and a vertical component of 3. If you notice, we've just doubled up on the 3, but that'll have no impact. To have a vertical component show up once or twice in the function has no impact on the range itself. Once is just as good as twice for purposes of determining whether an element is in the range. So we see that our domain is -5, -3, -1, 3, and 5. We simply recall the numbers on the x-axis that we colored in red. And similarly, the range is 2, 3, 4, and 5. We simply recall the numbers that we colored in on the y-axis. Okay, so the next question is to determine the domain and range of this function. Well, unlike the previous one, this one is a continuous function, and we have to consider that. Well, we're going to pretend that we can actually pick out each point and individually analyze each point. I'll start down here. This point has a horizontal component of -4 and a vertical component of -1. As we continue up, we see that each point has a horizontal and a vertical component. And as we proceed along, we obviously can't check each point individually, but we can pretend that we could. And what we end up seeing is that we seem to be shading in only a certain region of the x-axis. We seem to be shading in the region of the x-axis in between and including -4 and -2, and we seem to be shading in the region of the y-axis in between and including 1 to -3. So we ask ourselves, like we did in the first week of school, if I had to describe this in set notation, how would I describe it? Well, the horizontal component appears to be everything from -4 to -2 inclusive, so we simply write that the domain is a set of all x's such that -4 is less than or equal to x less than or equal to -2, and x is an element of the reals. Similarly, the domain, we look at the vertical component, the vertical axis, and we see it's everything from -1 to -3 inclusive. So that's what we write. The range is the set of all y's such that -1 is less than or equal to y, less than or equal to 3, y is an element of the reals. Moving to the next question. Now this time we see that it's linear like the last one, but this is infinite in both directions. So we can begin the process of analyzing each point. For instance, I'll check this point right here. It has a horizontal component of 2 and a vertical component of 1. And I'm shading in the axes in red. But what I realize is that this is going to go infinitely wide horizontally in both directions. In other words, this arrow here tells me that it's going to continue the function to continue to go to the left infinitely. Every point will be included in the domain, every x value to the left. Similarly, every x value to the right will be included because as the function extends this way, its horizontal component grows infinitely to the right. Well, similarly, the vertical dimensions do the same thing. As this function moves down in this direction, we see that it'll go down infinitely. Every vertical component possible will eventually be included in the range, and similarly it'll move up infinitely, so every vertical component positively will ultimately be included in our range. So we see that our domain is literally the entire x-axis and our range is literally the entire y-axis. Well, how do we express that? Well, we simply state that there are no restrictions whatsoever on the domain or the range. So we can write the domain is the set of all x such that x is an element of the reals. Or more simply, we can state the domain is the set of all real numbers. Similarly, the range is the set of all y such that y is an element of the reals, or more simply, the range is the set of all real numbers. Moving to the next question, we have a parabola. We've all seen these in grade 10. Well, keep in mind parabolas are infinitely wide. Quadratic functions are infinitely wide. So we start with our vertex and we see that it has a vertical component of 4 and a horizontal component of 3. And as we proceed down this branch of the parabola, we see that our vertical components decrease and our horizontal components decrease as well. This point here appears to be the point 1, 0, so it has a horizontal component of 1 and a vertical component of 0. This point here has a horizontal component of approximately 1/2 and a vertical component of 2. And as we extend down this branch, because it's infinitely wide, we see that we will extend infinitely on the x-axis, infinitely wide to the left. Well, we also see that as we extend down this branch of the parabola, we're going to proceed infinitely down. And so our range is colored in red. We now need to check the right-hand branch of the parabola. Well, it's more or less a duplicate of the first branch with respect to the y-axis. It simply proceeds down vertically, so all of these vertical components get shaded in. But recall earlier we said whether a component is shaded in once or twice has no impact on what the range looks like. It's either 0, a component is either in the range 0 times, in which case we don't include it, or 1 or more times, in which case we do. So we're simply shading in much of this vertical component twice. The horizontal component will extend infinitely wide to the right, and we see that if we were to express this horizontal axis in terms of set notation, we would say that the domain is the set of all x's such that x is a real number, element of the reals, or simply the domain is the set of all real numbers. And similarly, if we were to look at the vertical component, we'd say that we begin at positive 4 and we go down. We include positive 4 in our range, so our range becomes the set of all y's such that y is less than or equal to 4 and y is a real number. Now we have a circle. This circle is actually x squared plus y squared equals 16. And we see that as we go along the circle, this point here has a vertical component of 4 and a horizontal component of 0. And we see that similarly other points, as we move along the circle counterclockwise, or excuse me, clockwise from the top, we see that we end up shading in all of these points in the x-axis and all of these points in the y-axis. And as we continue along here, we see that we continue to shade in, let's say this point for example, we continue to shade in all of these points for the second time, but now we're shading in new points on the vertical axis. And so we see as we proceed around the circle this way, we've shaded in this entire vertical axis once, and this horizontal component of the x-axis twice. Now we proceed up this way. We reshade this component of the y-axis, but as we proceed this way, we've now included new horizontal components for our domain. And now we proceed along the last quarter of the circle, we duplicate this part of the x-axis, and we duplicate this part of the y's. And we see that we've included every horizontal component from -4 to 4 inclusive, and every vertical component from -4 to 4 inclusive. So, our domain is the set of all x's such that -4 is less than or equal to x less than or equal to 4. X is an element of the reals. And our range is the set of all y's such that -4 is less than or equal to y less than or equal to 4, and y, excuse me for that, y is an element of the reals. Last one we're going to look at here, we look at this component of the function, this component, and this component.